Hi, welcome to Future Trends in Construction, Change Becoming a Reality. As we've been discussing in this course, I'm Tom Stephenson, and today we get to look at possibilities, the way the world is changing, how this may impact construction. And so I've broken this into two parts. We've got 8A and 8B. So we'll look at 8A right now, and one of the parts in 8A is really discussing productivity, and one of the biggest problems in construction definitely is productivity. Huge opportunity. Problems can be flipped around to be an opportunity. If we reframe things and look at it from a different perspective, like I discussed in the first lecture of the course, when we're talking about change, this can be a big opportunity. All right, and so we're going to look at some of the emerging trends and digital technology, and in this portion of the lecture we'll look at building information modeling. So speaking of productivity, construction, not great. A lot of research points this out. There's a lot of areas that you can look at. Most of the research comes into a zone something like this, depending on what you look at, 32% waste. If we actually look at lean, which I'm going to discuss in another lecture with you, which is adding value and removing waste, which is become a big deal in construction for these reasons, that lean would say that you have around 60 to 70% waste, but it actually counts this as waste as well, but it's necessary waste. This is unnecessary waste. This is necessary waste, but it's still an opportunity if we can do it more effectively, more efficiently to reduce it. This, let's face it, we need the windows, we need the walls, we need the roof. That's part of the structure. That's the building. This is like absolute. This is absolute value adding. You do a schedule, the client, when they take over the building, they don't necessarily see the value in the schedule. They may appreciate that it finished on time, but the building itself is the building, right? Well, most people will look at this, but when we talk about lean, you'll see I'll shift gears a little bit in another lecture. But recoverable lost time, this is a huge opportunity. So I'm not standing here saying that we've got 2% waste in construction. How do we get it down to 1%? I'm saying we've got 32%, big opportunity. No matter where you look, The Economist, this was from 1997, had a big article on waste in construction and improvements in productivity, how fast you're able to do something with certain inputs, what kind of outputs do they produce, right? And so if we improve on that, that means with less inputs, we get more outputs. And that really ties into the ability to meet schedules, the ability to be cost effective and productive in construction. And this is what clients expect, but we as an industry globally have not been keeping up with the changes in the rest of the world. Total economy has been improving at about 3% productivity rate per year, manufacturing closer to 4%, and construction less than 1%. So we have not been keeping pace. There's an excellent report that was put out by the McKinsey Global Institute. I think this link, let's just check if it actually works. So I'll see if it works. Yeah, we're okay with that. So this is the productivity report, which is showing, this is the executive summary. This is the short gist of it. If you click on that, you will be able to see this report. It really sort of ties into how construction needs to improve in productivity, and it actually has done a lot of research and input into it and where the opportunities are. And so lean plays a big part into the report. Integrated project delivery type contracts play a big part into it. So there's a lot of things we can have influence on in the construction industry. Where I kind of get into it with my students is usually on the aspect of, well, what can you influence managing a project? site supervision, project management purposes. And that I'll get into in much more detail in another lecture. For now, I just want you to kind of have a broad sense of what's going on. And so when we think about this from this perspective, we have let's say this is a financial statement, a high-level financial statement. This would be an income statement. And you have, let's say you're a subcontractor, and you have 100 million in sales in a year. You have your own employees. Maybe you're an HVAC subcontractor or a plumbing or electrical subcontractor. You have $40 million that is your own people doing the work, the trades. You have materials, you have equipment, you have subcontractors. And so if we take that off the top line, what we have less is what we call our gross profit. Our gross profit includes overhead and profit. That's the gross profit. If we take out the overhead, and overhead is things like your office, your truck, your cell phone. That's expenses you're going to incur whether you had this particular project or not. So that is overhead. If we subtract that out, you have about $4 million profit, and that's 4% of sales. People think that construction companies make 25, 30% profit. That is not typically the case. Usually it's in this range of 4 to 10%. All right. So let's say it's 4%. Well, if you improve your labor, the productivity of your labor by 10%, that would then make the labor cost 36 million. Look what you did to your profit, your bottom line. 8 million. You doubled your profit, right? So now you've gone from 4% to 8% with a 10% improvement on your productivity, right? 10% improvement on your productivity on your own forces in labor. That's a big number. So a small improvement in productivity gives you a big improvement in profit if you self-perform a fair amount of work like a subcontractor in this case. And that number wouldn't be out of line for a subcontractor in that case. Or it wouldn't be out of line for a GC that self-performs on their concrete. So you might think 10% is a lot. All right, well, 5%. 5% would give you a 50% improvement on your productivity. 2% give you a 20% improvement on your product. 1%, 10% improvement on productivity. So that will give you an immense improvement in these areas. And so that's why the McKinsey Global Institute report, that's why lean construction, that's why BIM, that's why most of the things we talk about in this lecture is a result of trying to improve productivity so we can make better sense of being more reliable, reduce variation in the construction process. And if we reduce variation in the construction process, we become more reliable and we reduce variability. And that improves predictability. That means when we price things, more likely to happen the way we thought. When we schedule things, more likely to happen the way we schedule it. And if we do that, we're going to have happier clients because we're going to be adding value to them. And that's going to make us more in demand. And we will win the rate of competition. We'll have the competitive advantage. So there's a lot of contractors that are moving towards lean construction. And the definition of lean construction is adding value while removing waste. So in this particular lecture, I'm just going to give you these 8 components, 8 types of waste that we deal with in construction. And in another lecture, I'll get into defining these in more detail. But defects, things that weren't constructed properly, waiting, big thing in lean construction, we use the term workers waiting for work and work waiting for workers. Workers waiting for work is no good. The clock is running, you're spending money for no reason. Things getting done ahead of time is no good if you've got, basically, it's sitting there. And on the assignment project that I give many of you, I'm getting emails. Sir, we've been photographing this for 5 weeks and we haven't seen any change in the project. That is work waiting for workers. So it's not abnormal, unfortunately, and I'm not surprised. But that is tying into that. Transportation of goods. How do goods, transfer? How are we transporting them? What's the wait time? Stuck in traffic? Are we bringing things from another continent when we could get them close by? What are some of those issues? Wasted motion. I could spend a week on this topic. Wasted motion, inefficiencies in the workforce, inefficiencies with the trades, doing things twice, walking half a kilometer to a portable washroom and walking back. The time that's in wasted motion. Inventory, having too much on site, having to move it around multiple times. Overproduction, doing more of something that is required. Prefabbing a whole bunch of extra stuff and then it sits there and it gets thrown out. Unnecessary process steps, doing things that is not in an efficient way. So that happens all the time. Submittals and all the steps that are involved. Is there a productivity software we can use to improve that? Incorrect use of talent or underutilized talent. Not engaging with the people that are working with you. You do not know everything. They have much more expertise in their areas of skills. Have you engaged with them to take advantage of that? That's a missed opportunity. So that's a little quick introduction to some of the lean aspects, but I'm going to talk about that more in a future lecture. Emerging trends in construction, role of innovation. Really, that's what we're trying to do. We're trying to do more with less resources. That's improving productivity. Have less work waiting for workers and less workers waiting for work. And we can use a lot of innovative tools and techniques. Some things are very fundamental. To be honest, with lean, some things are fundamental in how we organize stuff, and some things don't have to be a high-tech solution. But we are at the cusp of humongous innovation, and the construction industry is a laggard at adopting it. With that said, we're at a tipping point where we're going to see massive change in construction. And so we're going to talk about some of these things. You know what? Some of these things may not end up being the be-all to end-all that I may mention here. There may be other things that are used in different ways that actually take advantage in different ways. Building information modeling. I couldn't 7 years ago, fully comprehend all the ways that it's now being used. And I still don't comprehend how it's probably going to be used in 10 years fully, because it's in the innovative state. It's in the growth state, but it is not going to disappear. So these are some of the topics. I mentioned the lean construction adoption. If you're a larger company, whether you're adopting pure lean principles, I don't see how you cannot listen to those 8 areas of waste when you're planning a project. So if you're not, you are falling behind, in my opinion. Prefab, you'll see some of the advantages. So we're going to go through these in the next 2 lectures that you'll see. Prefabrication, you know what? That's not new. We've been prefabricating stuff for a long time, but it is now at the threshold, tying with other technologies, to be able to do it in a much more sustainable fashion to a higher quality level and a higher certainty that it's going to work with the combination of prefabrication and BIM. It's helping to drive lower prices by scaling. So framing, we used to always frame on site, and we still frame on site probably for 50% or more of the work, but most of the production builders don't frame on site. They get the panels made and then they can quickly assemble them on site. So it shortens the assembly time and they'll do it that way. So there are a lot of these aspects. Factory built prefabricated buildings. They must meet building code requirements when they're put on the actual site, and they have to satisfy CSA requirements when they're for the components that are built in the factories. So there is but you're seeing more of this, not less of this, especially when we want to build real energy efficient, tight buildings. There are a lot of opportunities. If I think that the easiest way to build net zero out is likely coming out of a production builder that is using modularization to accomplish that. Some of the disadvantages are you have a factory and so you've got a lot of overhead. And in a down economy, because construction is cyclical, that becomes problematic. The other problem is getting it to the site. So you bring it to the site in sections and assemble it there. Mattamy Homes a few years ago built the whole project, like the houses, in their factory. They had some issues with that when you have up and down economies and things of that nature. But that doesn't mean that that's not going to still happen. People are tweaking things and people are seeing the opportunities and thresholds that these bring. Prefabricated homes, they've been around a long time. But you are seeing a renaissance in that and an opportunity, and you're seeing a lot of investment being placed into the modularization and prefabrication of condominium units too. So I suspect in a few years you're going to see a lot more in that kind of area where you're able to put together larger components and the house gets built this way. This is using trusses, and then you can see the prefab components, and this looks like a dormer that's built into it. I'm pretty sure, unless I'm mistaken, that might be in Kingston. There's a house right on the edge of Kingston, that particular one. Here's a condominium unit, prefab units being installed. You see that with prisons. They do the cells prefab and they install them. You see that in hospitals. So there's a lot of opportunity there. There's advantages, there's disadvantages, but these disadvantages can be really like this one can be really mitigated with better design and BIM design that ensures that it's done well. So there's a lot of improvements in those areas. Transportation tends to be the biggest barrier in prefabrication. But there's a lot of opportunities in this. And as I said, it will definitely improve productivity. So sustainable construction, this is whole courses. This is huge. I've mentioned net zero in some of my other courses that I do, and net zero means that the building produces as much energy as it consumes. We are living in a planet with ongoing climate change going on. This needs to be done. This will be done. Governments are changing building codes to be constantly more energy efficient. So to have economic sustainability, environmental sustainability, social sustainability, this all ties together for sustainable construction. Costs of building sustainably have gone way down. They're continuing to go down. And it's just like electric vehicles. Their usage is going way up. Car manufacturers are changing things over. Yes, it may take a little bit of time, but it's actually, these things sometimes, it took a little bit of time to get to this stage, but then things reach a tipping point where change becomes very rapid. So it's not going to be, I sometimes think about LEED programs and the certification programs they have. At some point, they're just going to be building code, and that's just the way we do things. So involves design management of buildings, looking at life cycle costing. We talked about in another course. What is the life cycle investment in this? What's our best mechanism for this? Build a tight envelope, make it very energy efficient. That's going to lower the cost of upgrading to more renewable resources as they become more available and cost efficient. So there are these elements that tie to this: adherence to ethical standards, socially viable environment, stakeholder participation, make it safe working conditions, innovative financing models. All of these things work together for us to be able to build more sustainably. And remember, the definition of sustainable is that not only for our generation, but for future generations, the transference of the infrastructure that we have is not impacting our environment in a negative manner. Whereas green, building green is just you're building better than the building code, right? Usually about 25% better than the building code. Smart building technologies, well, you know what? Everything is talking to each other. We're in a world where everything communicates with each other. And, originally everything was being wired a certain way for usage in smart buildings. But more and more you're seeing that it's going to wireless technology, which actually makes the implementation of smart building technology all that much more easier. Intelligent buildings are buildings that, through their physical design, IT installations, responsible, flexible, adaptable to changing needs from its users and the organizations that inhabit it. That's what it's all about. So, it's not about necessarily putting something in that's out of date tomorrow. It's about building buildings that are adaptable and flexible in more ways than one. And building automation is that integration of communication between your HVAC systems, your lighting, your building automation systems. There's a lot of ways that you wouldn't think that would be such a great deal. I used to think, oh, what's the point of being able to control your furnace if you're not at home? It's really kind of cool. If you're in another location, you can check. Maybe you're on vacation, you want to make sure your furnace is working. You can check that. You can adjust the temperature. You can be sent a notification if there's an issue with it. You can have your security cameras on, and you can have, as example, a Nest door buzzer, and it's got a screen that's a camera onto the street. A little story, because usually these things connect with stories. So just in the last few months, there was a murder down the street from where I live. And we actually had a Nest camera on the street. And so the police were canvassing the neighborhood, and they were able to access the video so they could see any cars that went up and down that street, right? During that time period, they could go in and they could check it. And then apparently, because the street kind of goes this way, there was somebody who had a camera going the other way, and they could check any cars that went this way. So they could actually see any cars that might have gone to that house. And that can assist them in tracking down who actually did the murder. So again, you'd be surprised at the different ways that this technology can be used for good purposes. I'm sure there's hacking and things that go on, but as we learn more and more about how we can better manage things, there's opportunities there. So building automation is that integration that takes place between the different systems in communicating with each other. Then we get to BIM, which is building information modeling. And that is the full integration of our building systems in the design. And when we're building them, there are the 6 levels of BIM, which really is level 3, 4, 5, 6. The 3-dimensional, 4-dimensional, 5-dimensional, 6-dimensional. 3-dimensional is your 3-dimensional model, which has all of your building systems in it, as well as your structural elements. And then you can look for clashes, interferences ahead of time, and you can resolve those issues in the model, as opposed to what we do now on the site. So that's not good. And I say now on non-BIM projects. Now on BIM projects, this also opens up the opportunity to do much more prefabrication of fancy ductwork and things that will actually fit when they arrive on site, meaning less rework, less people working on site because the installation time is shorter. Installation time is shorter, the schedules are shorter. Schedules are shorter, clients are happier because we can fit a construction process into a shorter time frame, and they can be utilizing their buildings quicker. So that has a lot of opportunities that way, as well as quality control, as well as you can run energy models tying to sustainability through a BIM model to see how effective the insulating qualities are of this particular building. So not only can you have it for the structural, for the building systems, you can also have it for operational use so that it can have energy modeling done. A lot of advantages to those areas with a BIM model and a full integration. And the client can actually walk through their building before they actually have the building completed. So that works. So there's good advantages there with building information modeling. And this is the way that we are beginning to do things. Any complex project is doing things this way. Hospitals are doing it this way. Data centers are doing it this way. And more projects every day, because as the trades catch on and as the consultants catch on and we get better and better at this, it's just the way things are going to be done. So It's definitely an emerging trend, and it's integrating everyone into that trend. Nobody is outside of that trend. And 3D looks for the clashes, provides opportunities for prefabrication, um, how we are going to assemble things. So it's 3D. 4D is how we schedule it, and we can animate the schedule so that we can actually tie it to a timeline. 5D is estimating, so we can do takeoffs. 6D is where we can integrate with the actual owners and provide them with a complete database of how their building is going to function, operate, and be maintained into the future. So a lot of advantages to BIM with that integration. And to help reduce the sort of lack of coordination and fragmentation that we have, where we're all of a sudden on site, oh, this doesn't fit, this doesn't work. I was just in another class and I was asked, are the consultants, do they care about the other areas? And, usually they do, because it comes back to them eventually that there's some design error or design problem. But the ability to integrate on the model definitely helps, because you're engaging with the people involved in the project. So this is really a big help. I talked about lean. That's really a big help. If we can get more companies working on IPD, integrated project delivery, where there's profit sharing in the construction process, that will be a big help. And you tie these things together, now you're really moving forward in accelerating your productivity rates and reducing waste. So direct benefits: visualization, coordination, clash detection, prefabrication, construction scheduling, construction simulation, quantity takeoffs, and you have a record of the model. Lots of different software. Software is changing by the day, so this is one listing. BIM is not a particular software. BIM is the integration of the various softwares. So don't get hung up on a particular software, but it's the integration of the various softwares that ties in. Lots of different types of models: design models, construction document models, depending on what's being looked at, lead, contractor models, facility management models. So you think about the different ones, they're serving different purposes. Like lead, you're looking at energy, right? So energy modeling, better daylighting, happier, less sick building syndrome. The various consultants are looking for the models to ensure that the design is very functional with very little rework. So those are some of the different models of how BIM integrates. Now in 8B, a lot of the things we'll be discussing, besides what we've already discussed, is again utilizing that we can do more things in different ways and trying to reduce waste in those 8 areas. So if we think about the next section, it's going to be looking at BIM, it's going to be looking at integration of the lean principles of waste elimination, and what the new technologies can potentially do for us. So that's what I wanted to cover right now. I'm Tom Stephenson. Hope you enjoyed this sort of looking forward on the trends aspect in our introduction to construction course. So we'll see you next time, and have a wonderful day. Bye for now.